Hello everybody. In this video we are going to be looking at the solutions to the college prep refraction homework problems 1 through 5. Let's get started with problem number 1. A ray of light travels from air into a liquid as shown in the figure. The ray is incident upon the liquid at an angle of 30 degrees and the angle of refraction is 22.0 degrees. A, using Snell's law, calculate the index of refraction of the liquid. So we are given our angle of incidence, which is the angle right here. And remember, we always measure these angles from the normal. The normal is a line that is perpendicular to the boundary between the two mediums. So the angle from my incident ray to the normal is going to be 30.0 degrees. My angle of refraction, which again is measured from the normal, is 22.0 degrees. If I'm traveling from air, I know that the index of refraction for air is 1.00. And remember, we can get the indices of refraction for different things from the table in the PowerPoint. You could also Google it, or you can also find it in the formula sheet that I have posted in the toolbox on the website. So we are trying to solve for the index of refraction for the liquid. So starting off with Snell's law, I know N1 sine theta 1 equals N2 sine theta 2. Solving that for N2 will give me N2 equals N1 sine theta 1 divided by sine theta 2. Plugging my known values into that equation will give me an index of refraction for the liquid of 1.33. Second part is they want us to compare the calculated index of refraction, which we have is 1.33, to those that are on the table in the PowerPoint, and from that determine what this liquid is. And when we look at that table from the PowerPoint, we see that there is one liquid that has an index of refraction of 1.33, and that liquid is water. Problem 2. Light travels from flint glass into ethanol. The angle of refraction in the ethanol is 25.0 degrees. What is the angle of incidence in the glass? Looking at the table of the indices of refraction that we can find, as I said, in several different places, I know that the angle or the index of refraction for flint glass is 1.66. The index of refraction for ethanol is 1.36, and my angle of refraction, or theta 2, is 25.0 degrees. They are asking us to solve for the angle of incidence, or theta 1. Starting off with Snell's law, we are going to solve this for theta 1. So to solve this for theta 1, I am going to first have to divide both sides by, oops, that's not an I, that's an N, N1. When I solve both sides for N1, I still have sine theta 1 on one side of my equal sign, and I need to just solve for theta 1. So I have to take the inverse sine of both sides. When I do that, I'm going to have theta 1 equals the inverse sine of N2 times sine theta 2 divided by N1. Plugging all of my known values into that equation will give me an angle of incidence of 20.3 degrees. Problem 3. A beam of light strikes the flat glass side of a water-filled aquarium at an angle of 40.0 degrees to the normal. For glass, which has an index of refraction of 1.50, the first thing they want us to find is at what angle does the beam enter the glass. So we know that the beam is initially traveling through air. That air has an index of refraction of 1.00. The index of refraction for the glass is 1.50. and the angle of incidence is 40.0 degrees, and we are trying to solve for my angle of refraction, or theta 2. Starting off with Snell's law, solving Snell's law for theta 2, and we'll see about this subscript in just a moment. Solving for theta 2 will give me theta 2 equals the inverse sine of n1 times sine theta 1 divided by n2. And plugging all of my known values into that equation will give me an angle of refraction of 25.4 degrees. Part B of problem 3 asks, at what angle does the beam enter the water? Now, because both sides of the glass are parallel to one another, the angle of refraction from the air-glass boundary is going to be the same as the angle of incidence at the glass-water boundary. And that is just your alternate interior angles that you should remember from your geometry class. And why wouldn't you remember that from your geometry class? So if we have two sides of the glass here, and we have a beam of light that is traveling in there, let's draw a normal here. I'm going to draw a normal here. And then my beam of light is going to bend here. And then I'm going to draw another normal where it goes. This is, by the way, air, water, and this is my glass. This angle and this angle are going to be the same. So those are alternate interior angles. So I know that my angle of incidence is going to equal my angle of refraction, which is 25.4 degrees. The index of refraction for the glass is 1.50, and the index of refraction for the water is 1.33. And again, this is why I have this little subscript R and my I here, because those are the refractive and incident angles for the glass, which is theta 2, my second substance. So we are solving in this case for theta 3. It could be theta 2 all over again, but I just wanted to keep them separate. So I know that solving for Snell's law, and now I have n2 sine theta 2 incident equals n3 sine theta 3 incident, right? And solving this for theta 3, and again, I'm just using subscripts 2 and 3 instead of 1 and 2, just so we can keep track of stuff. So theta 3 equals the inverse sine of n2 sine theta 2r divided by n3. And plugging my known values into that equation will give me an angle of refraction into the water of 28.9 degrees. Problem 4. Refer to the table of indices of refraction in the PowerPoint. Use the index of refraction of a diamond to calculate the speed of light in a diamond. So my index of refraction for a diamond is 2.419. I get that from the table that is in the PowerPoint, or you can Google it. Hopefully you'll get the right answer when you Google it. Sometimes you don't. Or in the formula sheet that I have posted in the toolbox on the website. My speed of light in a vacuum, C, is 3.00 times 10 to the 8th meters per second. And we are trying to solve for the velocity. I know that the index of refraction is equal to C divided by V. Solving that for V will give me V equals C divided by N. So 3.00 times 10 to the 8th meters per second divided by 2.419 will give me a velocity of 1.24 times 10 to the 8th meters per second. Problem 5. A thick sheet of plastic with an index of refraction of 1.500 is used as the side of an aquarium tank. Light reflected from a fish in the water has an angle of incidence of 35.0 degrees. At what angle does the light enter the air? So this is going to be just like problem number 3. The light has to go from the water to the plastic, and then from the plastic to the air, and it's going to refract at both of those boundaries. So I know that in this case, the water is going to be substance 1, the plastic will be substance 2, and the air is going to be substance 3. So my index of refraction for the water is 1.33. My index of refraction for the plastic is 1.50. And my index of refraction for the air is 1.00. My angle of incidence in the water is 35.0 degrees, and I am looking for the angle of refraction into the air. I'm going to start off with Snell's law to find the angle of refraction for the light wave going from the water into the plastic. So I'm going to start off with Snell's law, and I am going to solve Snell's law for theta 2 refracted, or the refracted ray going into the plastic. Solving this for theta 2r, or the refracted angle in the plastic, will give me theta 2r equals the inverse sine of n1 sine theta 1 divided by n2. Plugging my known values into that equation will give me an angle of refraction into the plastic of 30.6 degrees. And again, because the two sides of the sheet of plastic are parallel to one another, according to my alternate interior angles, I know that the angle of refraction from the water plastic boundary is going to be equal to the angle of incidence at the plastic air boundary. So theta 2r is going to equal theta 2I. Solving now for theta 3, again using Snell's law, I know that theta 3 is going to equal Theta 3 is going to equal the inverse sine of n2 sine theta 2r divided by n3. Plugging my known values into that equation will give me an angle of refraction into the air of 49.7 degrees.